Welcome to LNP Renewable System Reactor. Today we're going to see the duct temperature sensor basics. Okay, so in the discussions, what are the things that we're going to know? Okay, so what is a duct temperature sensor? Okay, why should we know about it? Okay, where can we see this duct temperature sensors? Okay, how it looks like, how it works, and what are the things as a building management system engineer or tax engineer we should know in the duct temperature sensor. So duct temperature sensor is used for sensing the air temperature, especially in the HVAC system, that is heat ventilation air conditioning systems. Okay, we used to install them in the fresh air ducts, supply duct, okay, return duct, even in the mixed air ducts also we used to install this duct temperature sensor. So this is how it is getting installed in the ducts. Okay, as I told earlier, it will have a stainless steel duct probe, okay, which will be inserted in the duct, and in the outside you can see this external coverings. There are so many models which is available in the market. Now let us see a simple example of the Greystone. So as you can see here, this is the sensor wiring, okay, the probe which is getting connected here, and most importantly, if you want to uh, get the output, if you want to convert the proper temperature to the required output, say for example if you want as a milliamps current or a 10 volt 0 to 10 volt DC, so based on the sensor that you're choosing, because now we have a sensor which produces an output of 4 to 20 milliamps, so it's in the milliamps range. Okay, so say for example, there are so many ways of wiring this, so we will try to know about it in depth. Say for example, if you had a plan to uh, connect from the AI module of a PLC, okay, you had a plan to get your output in the 4 to 20 milliamps current, so you can connect in the power and also you can take from the output. So this is how you can do your wirings. So in depth in your the wiring diagram, we will try to know more things about this temperature sensor. So as we told earlier, this duct temperature sensors will be installed in the ducts. We have so many ducts which will be going through the buildings as well as in the metro stations, especially in the heat ventilation air conditioning system. We will have the supply duct, return duct, and most importantly in the air handling units we used to use these temperature sensors. So as we told earlier, so this is the wiring diagram. As you can see here, if you had a plan to provide the 0 to 10 volt output planning, okay, if you want to take the voltage as an output, uh, that is from the sensor, that is going to be your analog input to your devices. If you had to plan for a three wiring sensor, it means 24 volt DC you can connect in the power output, you can connect with your 0 to 10 volt AI provision of your controller, and then common you can connect here. So this is a three-way wiring, or in other words, say for example, right now we see a sensor. This is an example of a 4 to 20 milliamps output. So that for that you need to do the wiring like this. Okay, from your controller, the 24 volt you connect with the power. Okay, and output you please connect with your analog input module, so that whenever, say for example, if you're trying to provide a 20 milliamps, okay. Um, uh, from your analog input controller, what will happen, because of the temperature changes, okay, you won't get the exact 20 milliamps feedback. You will get either 4 milliamps, okay, there is no change. Now if it is a 0 volt, if it is not operating properly, or a minimum temperature you will get, otherwise you will get 6 milliamps, okay, 8 milliamps, or 10 milliamps, or sometimes 12 milliamps, or 16 milliamps, or sometimes 18 milliamps, even 20 milliamps output also you will get based on the sensor that you're going to choose. Okay, or if you want the same voltage output, but you had a plan to provide a 24 volt DC externally, means you can do the wiring like this. Or even for the same 4 to 20 milliamps 20 milliamps feedback you need, but you want to provide a external power circuit provisions, you can do the wiring like this. Okay, so this is the simplest wiring that you can do for in order to measure the temperature inside the ducts. So say for example, this is the base, analog input base. Say for example, let us consider the Rockwell, okay, Rockwell analog input model IE8 AI module. If you had a plan to do the two wiring, you can do like this. So as you can see here, I will be connected, and through the power you are connecting your temperature sensor. So it is in series you're going to connect, so that even if you give 20 milliamps here, okay, 20 milliamps here, your output from the temperature sensor is going to differ. It differs from 4 to 20 milliamps range. So that based on the change in temperature, you can uh, you know get based on the change in temperature, we will get the change in current outputs from the temperature sensor. So this is and most importantly, we all should know how to measure the current. So as we told earlier, so consider this is a 24 volt DC supply, okay, and this is your sensor, okay. So as you can see here, this is installed in the duct. Okay, these are the two provisions you have. So one is a power provision, and other is going to be the output provision. Okay, so as I told earlier, if it is a 24 volt DC, okay, 24 volt DC output, okay, this is going to your temperature sensor. Connect your commons directly, okay, and change your probe in the digital multimeter in the current and the common connections, and change the settings as milliamp settings, so that connect your positive here and in the negative here. So connect, always try to connect your multimeters in series, okay, so that whenever there is a change in temperature, okay, whatever the voltage that you give, you won't get the exact as a feedbacks, okay. So what it will happen is, consider this as an analog input model. You itself going to provide the provisions, so you will get an output current in the range of 20 milliamps, 4 to 20 milliamps. So this is a simple video which describes how when the temperature is low, you will have a very less amount of voltage output, microvolt output. When the temperature increases, the output voltage also increasing. The same way, current also will change. So, see here, the temperature increases, the microvolt output also increases. When the temperature is less, the output is very less. In the same way, the current will also change. Thank you so much. Please subscribe to our channel and press the bell icon. If you want to know more and learn more, please follow our channel and share this video to everyone. Thank you so much.